have the linear inequality here, or one variable inequality, that is x minus 3 is less than 0. So I can solve this inequality by just adding 3 to both sides, and I can see that x is less than 3. I can also solve this inequality by graphing the linear equation y equals x minus 3. So it's a straight line with slope of 1 and a y-intercept at negative 3. And since this is a linear one-dimensional or one-variable inequality, a linear equality meaning it's a straight line, but it's a one-variable inequality meaning we have a one-dimensional solution. So when I graph this, since the boundary is going to be at x equals 3, that represents my boundary. Okay? And when I look at the graphs, I'm just going to draw a straight line because this is, again, one variable. So we're not concerned about the two-dimensional line here. We're just concerned about the one-dimension x-axis. So at x equals 3, I want all the solutions on this side. Okay? So I want to know when this graph is less than 0. The graph is less than 0 for this portion of the graph. Okay? So this is not the area that I'm talking about, but in fact, maybe just to be clear, it is this part of the graph that I want. Okay, and this part of the graph represents my solution at x equals, or x is less than 3. Okay, so there's my solution there. And again, I can show that solution by solving algebraically, and I get x is less than 3. So this is a linear inequality because it's a straight line, but it is a one-dimensional inequality, so my solution is along the x-axis. Okay, and I show it in one dimension. So how does this inequality differ from a two-variable xy inequality? Well, although I graph this line in 2 dimensions, and I'm using the two-dimensional line to help me solve this, it differs from xy inequality in that the solution is one-dimensional. Meaning it is on the line. On the x-axis. Okay, so the solution is along the x-axis. So this is a linear inequality of one variable. Okay, and we have a one-dimensional solution. Here we have a quadratic inequality. Now, quadratic inequality is also a one-variable quadratic inequality, so the solution should also be one dimension. It's always good to be able to visualize this, so we are going to use a two-dimensional graph to do this. But we can start solving this kind of analytically by just plugging in some numbers. So we can think of some numbers that satisfy this inequality. So x equals 1 would work. Okay, x equals -1, x equals 1.9 or -1.9. Okay, what doesn't work is numbers like 4, or let's just go 3, or -3. Okay, -3 squared is bigger than 4. 3 squared is bigger than 4. So all these numbers, 4, -4, etc. ... Okay, so how can we solve this inequality? How can we solve this and reduce it to a linear inequality? Well, we can solve these quadratic inequalities by reducing them to linear inequalities by doing this. So first of all, we're going to make it less than 0. Okay, and what we can do then is quadratic equations can be solved by factoring them into linear components. In fact, any higher degree polynomials, if we can factor them, we can reduce them to linear parts. And if I factor here, and again, as long as it's something to do with 0, the factors, we can find the boundary where it's equal to 0, okay? And factoring is no point if we don't have it equal to 0 because we want to use a 0 property of multiplication. But here, if we factor, we can now say that, well, my boundary, and we can kind of see it here, my boundary was 2, and -2 will get me to the boundary point. And we just have to figure out which side of the boundary we're on. So my solution, since it's a one variable inequality, my solution is going to be on a line. I know my boundaries are going to be at 2 and -2. And really, I just need to know which side of the boundaries are going to be part of my solution. And if I just test this, I can just test, well, yeah, I tested up here. My solution is going to be these numbers here. Okay, and those numbers happen to be between -2 and 2. So that represents my solution. Okay, all these numbers in here. All the numbers 3, -3, they're all on the outside, and they represent numbers that do not satisfy this inequality. So again, the key to any equation or inequality is the boundary, which is an equal to point. And by making it the inequality equal to 0, we can find the boundary zeros by using the zero property multiplication and factoring a quadratic to then solve these linear parts individually.